So if you haven't watched question 9, please start with that. It says rank the following in terms of increasing melting point. Melting point and boiling point are directly proportional to lattice energy. So increasing melting point means increasing lattice energy. So let's take a look here in terms of how we're going to do that. But before we do that, increasing melting point means smallest first. So as before in the previous two questions, the first thing we need to do is get the charges. So strontium is in 2A, so it's plus 2, and sulfur is in 6A, so it's minus 2. Rubidium is in 1A, so it's plus 1, and iodide is in 7A, so it's minus 1. Cesium is in 1A, so it's plus 1, and iodide is still minus 1. So we use the charge difference and the size. The charge difference is the bigger factor. So here we have plus 2 to minus 2. The charge difference is 4. So therefore, this one's going to have the greatest lattice energy and the greatest melting point. So this one will be last. But between RBI and CSI, they both have a charge difference of 2. So we have to consider the size. Rubidium is smaller than cesium. Iodine is obviously the same size. So rubidium iodide is going to have a slightly larger lattice energy than cesium iodide because rubidium is bigger than cesium. So the absolute smallest here is CSI because the smaller the ion, the greater the lattice energy. So this has the biggest ions and therefore the smallest lattice energy. That's going to be less than RBI, which is going to be less than SRS. So this is how we can rank our lattice energies. Be aware that lattice energy can be asked for ionic compounds in terms of melting and boiling point as well.